Today is the 25th, and today is the big day. Um, we are going to cross that bridge today and learn about the quadratic formula. I did not accidentally choose capital letters there. Okay, it's a proper noun. It's like a thing. It's like it's got its own like special place in the world of math. So capitalization there. It is not the quadratic equation, just for the record. I won't harp on you about this, but it is the quadratic formula and it is used to solve quadratic equations. So the idea here today is that we're going to be faced with quadratics that we can't necessarily factor. And so, what we spend our time doing and what you already quizzed on before is I give you a quadratic, and I don't know that I would ask you to write this one down because you may look back at it someday and be confused. But like if I gave you x squared minus 2x minus um, 15, like you can solve this by factoring.
Nation. Today is April 25th, 2025.
So, a quadratic equation like this, you would just factor down into x minus 5 times x plus 3, right? So, the idea here today, and again, I wouldn't write this down because we've already learned a lesson on this. And the point I'm trying to make by showing you this example is that not all quadratics work out all cute and fluffy like this. So, we're going to be faced today with some problems, and there's going to be a mixture, but some problems where you just look at it and go, I can't. And that's reality is that not always are you going to be able to find magic numbers that make these cute little things happen. So, like I said, you took a test on this. You did very well. Assuming you were here and that you took it. These tests, I remember, went very well. So now we're faced with situations like this. So this will be the first time that we ever together solve a quadratic equation that cannot be solved by factoring. And this is what you'll need to get used to. This is where we're heading today and the next day or so. All right, let's do this. So what is step one? You already know this. Yeah, you guys are good. Add that 6 to the other side because we know instinctively, like we're not really going anywhere with anything until we make it equal 0. And by the way, using the quadratic formula is a no-go until you make it equal 0, just as if we were going to set it up for factoring. So we're going to leave the 3x squared and the minus x alone, but when we add the 6 across, it turns into minus 6, not minus 18 or something silly like that. So we approach it as if we were going in for the factor. And then we realize, and I'm not going to waste your time by asking you to do this, but if I put this on a test and said factor it, I would be pretty mean because what you'd realize after about, for some of you, 30 seconds, for some of you, a couple few minutes, is that I'm sorry, I can't find the answers. And the reason is because they're not there. So hence what we're learning today is how do I solve a quadratic equation when the cute little factoring technique doesn't work. So here it is for the first time ever. We're going to write it down. And if you'd like, I can teach you the little song. But there's a little song that goes with this. But the quadratic formula says this: your x values are always going to equal, here it goes, the opposite of b plus or minus, bless you, the square root of b squared minus 4 times a times c, and all of that is divided by 2 times a. And it is one of these things that you first see it and you think, okay, this is going to be tough. The fact of the matter really is that it's not. You should have all the requisite skills in place. If you can simplify square roots, and you did that work that we did yesterday, even if you didn't finish the entirety of assignment 50, if you know how to do those two things, simplify roots and simplify the yesterday homework, you're going to be just fine. It just looks like it's probably the most intimidating mathematical thing you've ever seen, but not bad. So first question logically is that's fine. Thanks for the formula, big guy. But like, what is this A, B, and C nonsense? So A, B, and C can be found right inside the quadratic equation. And the numbers that are in front of the terms are the values. So like in this case, in this quadratic equation, A is simply equal to 3. I would write that down. I still been doing this for years and I still write down my A, B, and C values. I don't like to just leave them sitting in the equation. I like to literally pull them out and see them with my own eyes. My B value will sit right here. What is B? It's not a 1. It is, however, a -1 because there's a minus there, right? And we know how minuses and negatives are kind of like sometimes interchangeably a little bit. And then, of course, what is C? Nice job. So for the first time ever, what we're going to do now is we're going to embark on putting numbers into the quadratic formula. And after a little bit, a couple minutes from right now, you'll see why yesterday's homework existed. Um, it already probably looks a little bit familiar. Just the general structure, that purple thing up in the corner is number plus or minus root divided by something. Like there's a reason I wanted that whole assignment to look that way. So let's begin. The first thing you always do is you go to the first spot in the quadratic right here. And a lot of people, like when I sing you the song, it's going to be negative B, like you'll hear me say negative B, but you can also say opposite B. As long as you promise to remember that you don't always put a negative number where that yellow arrow is pointing. Because check this out. There's already a negative sign right there, right? So like if I take -1, because that's what B is, and I put it in place of that spot, what is that going to say? It's going to say +1. And I'm not going to write the x equals for a while. I'm just going to kind of let that go. So here it is. We're off and running. The negative B became a +1. And then I'm going to copy my plus or minus, and then I'm going to put a big, uncomfortably long square root sign like this. I'm going to leave myself lots of room inside that square root because I have to do some math. I would always do this step as I go. I wouldn't ever not do this. So the first thing we do, like I'm not saying is don't show your work on the B squared. What is B? It's not 1, it's -1. And what happens when you square -1? You get +1. So right here, we're going to put +1. And all I'm doing right now is I'm very meticulously taking that formula, the purple formula, and I'm just simply putting numbers in place of letters. Now, the next step, and if you're willing to trust in me, this will pay dividends for you. I would encourage you to just copy down the -4, and then where A and C used to be, I would encourage you to put just 2 blank spaces, just like that. I wouldn't even put numbers in there. I formed this habit a long time ago. And what I find is that I can spaz out, and kids can too. If I'm inserting numbers as I go, my eyes tend to maybe wander and see the wrong numbers. So you'll hear me say like -4 blank blank. You'll hear me say that 50 times over the next few days. So blank blank just means leave them alone. Now let's go to the bottom. The bottom of the quadratic formula right here says to do 2 times A. What's 2 times A in our case? Nice job, you guys. Now, at this point in time, what I'm going to do is I'm going to go backfill. I will never do the quadratic formula any other way than this. And again, now that my mind is cleansed and like I've done the whole rest of it, I could go back clearly now and make sure I pick the right guys to go in those blanks. Who are going to go in those 2 blanks? Nice. A is 3. C is -6. Are you with me so far? Rad. Now, we're one step away from this looking exactly like yesterday's homework assignment. And obviously, the square root, and I did debate this. I debated whether or not I should make you do a little inside the square root work, but I settled on yesterday just the ending, just the ending. So, what we're going to do is we're going to do the math problem. This is the hardest part of teaching or learning the quadratic formula, is to get you to be on board with what I'm about to do, to what I'm about to say. I need you to do the math problem in the yellow box. And it's not that complex, but this is where almost like 99% of mistakes happen. So we have to make some considerations. Um, the first thing I think we all notice, I'm going to do some erasing because I'm recording this. So like if people want to see stuff, they can go back and hit the rewind button. What I want to focus on the TV right now is just what's in the yellow box. And so the consideration here is that I'm going to point to a couple of things with green arrows. That, my friends, is a minus sign. And that minus sign, eventually, when you do the math problem in the yellow box, whether you want it to or not, it is going to come into physical contact with that negative sign. Do you see that? It doesn't happen right away, but who cares? Like it's coming down the pike. It's going to happen. What happens when a minus and a negative touch butts? Yes. So in reality, what you see in the yellow box does not say what you think it says. What it really says is 1 plus 4 times 3 times 6. Do you buy that? For real? Okay, good. Keep your life as simple as possible, right? If you see that it's going to turn into a plus, just make it a plus. But of course, you have to get rid of the negative. Like the negative can't stay there. That's double dipping. The minus and the negative is essentially sacrifice themselves to become the plus. And now it's just clean math. And the order of operations mandates, of course, that we perform multiplication first. So we're going to do those three numbers multiplied together. Forget the one, right? We don't add before we multiply. What is 4 times 3? What is 12 times 6? What is 12 times 6? What is 12 times 6?
72.
The voice of reason, 72. And if you do 1 plus 72, you get 73. And this will now look exactly like last night's homework assignment. Do you have any questions about how we got 73? Now, here's some good news and some bad news. The bad news is you're going to feel like a little bit let down. The good news is this problem is over. You stick an X and an equal sign and you put this in a box. And you might say, well, how do you know it's over? What if this were on last night's homework? What would have made you say, like, raise your hand and say, I need some help with this? I'm not, what about this makes us feel, Josh, like it's done?
It's not, you can make it small.
You sure can't, can you? Remember, job one in last night's homework was to look at the root of 73 and to pull it off to the side and make a tree. And you can sit here all day long and try to make a tree, and it ain't happening. 73 is like, nah, nice try. It's not going to work. So whenever you get a dead root at this point in time, you're actually done with the problem. And just for the record, so that you don't think this is a bunch of mumbo jumbo, there are two answers in that white box. Do you see it? What's one of them? Read me one of the two answers in the white box. X equals what? Go ahead. Nice work. And then what's the other answer in the white box?
One.
Correct. So I want to be clear that this is not an answer. It's two answers. We just are able to compact them into one like that. So there is how you use the quadratic formula. Now we're going to do a few more examples now that you've been through it once. And what changes is why last night's homework existed, is because at the end, different things can happen. How much work you have to do is entirely decided by that guy. It's all about him. If he's a dead root, those become our favorites because we're like, jackpot, baby. I don't have to do any more work. But sometimes he'll be a breakdownable root. Sometimes he'll be just a square rootable root. Maybe it'll be a 0. So there's all sorts of potential things that can happen. So I would say, do you have any questions about that? But it's probably a little odd part of the lesson because that's a lot to take in. So let's do another one. So for our second quadratic, we're going to do m squared minus 3m minus 3 equals m. I'm sorry to make you keep doing this, but the assignment on the computer is going to make you do this. So I thought, let's be consistent so you know what to expect. What do we do first? Good job. So our actual like equation that we're ready to solve is going to be what? M squared minus 4m minus 3 equals 0. You take a look at it and you'll see it's not factorable. So we proceed. What's A? Someone say, what'd you say? 1. Good. Variables are not part of your A, B, and C values. A, B, and C are just the numbers in front of the terms. What's B? Rad. What's C? And it's time. So you've already got the quadratic formula written in your notes, and now it's time to go and plug numbers in place of all the cute little letters. So let's begin. So we're going to say m equals, not x equals this time because we're not solving for x, m equals, and we're off. What's going to be the first thing we do?
No, put the 4 in front of the,
If we go back up to the quadratic formula, which is, oh darn, I erased it.
4 in place of the.
Yes, and it's not a 4, it's a -4. But the first thing that you encounter, look at your notes in the quadratic formula as you read it, is boom, right away I see, oh, someone's telling me to take the opposite of b. So if you put -4 in place of b and then take the opposite of that, the first thing you should write would be a 4. It's the opposite of this guy. Every time, +4. And then we're going to do plus or minus. And then remember now to do a square root sign, but to make sure that it's long enough that you have some room to show some stuff, because there's stuff. There's a big square root. What's the first thing that goes inside the square root? Correct. B squared. When you square -4, you get a +16. Let me ask you a question. Is this number right here with the arrow pointing at it, is it always going to be a positive? Yes, it is. And the reason is because whether B is positive or negative, you're squaring it. And when you square something, it's coming out positive. So your calculator, if you don't know how to use parentheses on a calculator, it might tell you a negative. Sometimes you overrule that. All right. Because you know that anything squared is a positive. So after the 16, I'm going to put minus and I'm going to put 4, and then I'm going to draw 2 little blanks and I'm going to move on. I'm not going to fill those. I'm going to do all over 2a. What is 2 times a in this case? 2 times 1 is 2 all day long. And now we're going back up into the root, refill, backfill. What goes in my 2 little cute parentheses? 1 and -3. So you know what's coming right now. You know, I think that what I'm going to ask you is this minus? I'm going to point to just one thing. Is this minus going to stay as a minus? Going to switch to plus? Why? Because there's a negative down the road after it, and minuses and negatives make pluses. So in reality, like, you shouldn't use your calculator for math like this. A 5th grader shouldn't use a calculator for math like this. But if you do, all you're really thinking of is 16 plus 4 times 1 times 3. Got it? The minus and the negative aren't there anymore because they work together to form a plus sign. And the order of operations mandates that we not do anything silly here. What's 4 times 1 times 3? And what's 16 plus 12? Yeah, like I said, we should not be using calculators just because we're allowed to. We use them when the numbers are making us uncomfortable. And this is what we get. So once we make it here, this time we do not put a box around this and move on our way, because why? Because like last night's homework, we realized, hey, there's still some meat on this bone. So we're going to take the square root of 28. I'm going to grab this thing right here because I can do this. You can't do this with a pencil, but I'm going to move it out here and I'm going to go work with it. Like, I know I can do some surgical work on you because I've done like 50 of these by now. So how do you break down a root 28?
74.
Yeah, make sure you put the 4 in the first one, 7 in the second one. And the answer then becomes 2 root 7. And now what I'm going to do is I'm going to take that version and plug it back in so it looks like this. Practice makes perfect, huh? And then it's time for the Dorito. The guacamole Dorito looks like this. Is there anything that the Dorito numbers can be divided by? 2? What does our final answer wind up being? Yep. And please do not put divided by 1. Just when there's a 1 in either of the places with the red arrows, they should never be there. It's not wrong, it's just creepy. So ones should only exist in the placeholder spot where the four's at. What's up, man? Nah, don't know. Good. That one went a little quicker. And feel okay? All right, let's go again. 4x squared minus 5x minus 5 equals 3x. What do we do first? What do we get?
-8.
So we get 4x squared minus 8x, I heard, minus 5 equals 0. What's A? Yeah. What's B? Yeah. What's C? Okay, we're rolling. And I am hearing the same two or three voices a lot, but my hope it's not just that those are the only two or three that are getting this. Everybody okay? Set it equal to 0, pluck out your ABC, and now let's plug them into the quadratic formula. So the quadratic formula says that the first thing we will do, so we are going to say x equals this time because this is an x problem. And what's the very first thing we do?
What would be the-
Do the opposite of B. Yep, that should be your answer. The opposite of B. Like, don't make a big math problem out of it. The opposite of B in this case is +8 because B is -8. It's the first thing you write, opposite B. And then you put down a little plus or minus sign. And then you draw a square root sign that is large enough to house a long math problem. First thing inside the math problem is, or the square root is B squared. What's B squared? 64 goes there. That's just -8 squared. And then I'm going to put -4 blank blank all over 2 times A, which is, and in those cute little blanks are going to go you should be right now at the lesson at the point where you are fully comfortable getting to where we just got to. That should be logically where you're at, is like, okay, I'm good at this now. I get it. And the question from here every time is going to be, and I'm going to ask this a lot, is that a stay minus or a change minus? It's a change, right? And there will be some that stay. Don't think it's always going to change. It's just I happen to pick 3 in a row where my C value over here was negative, and that minus and that negative, they may be a little distance apart, but they're going to find each other and hook up, right? So the math problem inside of the square root sign is actually 64 plus 4 times 4 times 5. Notice the negative is not there anymore. And this is one where I wouldn't give you grief for using a calculator because these numbers are a little bit more intimidating. So what we're going to do is we're always going to calculate things in the correct order. These 3 numbers in the yellow box have to be multiplied first. Order of operations is not up for negotiation. What's 4 times 4? 16 times 5. 80. Nice job. You redeemed yourself from earlier. And so what this math problem up here says is really 64 plus 80. And 64 plus 80 is,
1.2.
yes. This did not make the note card today as my third example by chance. I put this one here on purpose because I wanted to have this talk with you right now. What do we do next? Yeah, so we're going to take the square root of 144, and we know, because we did yesterday's work, that our job now is to go deal with that guy. Say 144, you're my focus right now. What do you do with the square root of 144?
Well,
It's literally 12. But these are the ones where I said, I don't want to catch you making a tree off of a number like this. This is where you use your resources and go, hey, I know you 144. You got a square root. It's 12. So what I'm going to do is I'm going to actually just put regular 12 right back up into my quadratic formula. And you'll remember maybe if you have a good memory that these are the ones I said we should call these pathway problems. Did that come up? Pathway. And the reason I want us to think that way is because I want to remember that I actually have to follow both pathways now to get 2 separated answers. So let's follow the red pathway first. That's called plus. What is 8 plus 12? What is 20 divided by 8? Well, it's 28ths, which is exactly 5/2. Nice job. Okay. Let's take the minus pathway, the yellow one. What is 8 minus 12? It is -4. 8 minus 12 is -4. And if you put -4 over 8 and reduce it, what do you get? -1/2. Now, this part is, if this makes sense, then this will be a big victory. The two answers to this problem, I'm going to do some erasing. Are x equals 5/2 and x equals -1/2.
At least for you yesterday, because I saw them.
Oh, thank you.
You're welcome.
Appreciate that. So I'm going to try to make a connection now that I hope you can make. I'm well past the point where scientists and researchers would say you should expect 15-year-olds to still be listening. I hope you understand what I'm about to say. Check this out. You might wonder, why did I just write that down? Here's why. The fact that your answers came out pretty like this means that the thing in the yellow oval could have been solved by factoring. Check my factoring if you want to. What's 2x times 2x? 4x squared. What is -5 times +1? -5. But then check this out. It's really cool just to see it for the first time. I'll be darned. Look at these. What do those make?
2.
What do these make? What's 2 minus 10? Listen, the quadratic formula always works. It even works when a problem could have been solved by factoring. And sometimes we have moments where we kind of had like we get in there, we do the quadratic formula, and we realize, I didn't have to do that. So I wanted you to see that connection, that sometimes factoring would have been a more quick option. But the thing about factoring is that it doesn't always work. But the quadratic formula always works. Yeah, man.
Oh, so on the test, if there's one where it can't be solved by factoring, would it be counted wrong if we could?
No. My goal for you on a test would be, I'm going to give you 6 or 8 quadratic equations, and I'm going to say solve them. And if I happen to sprinkle 1 or 2 in there that were factorable and you spot it, good on you. But the vast majority of your next test, I'll force you to use the quadratic formula. But great question. No, I don't mind if you work smarter, not harder. Yeah. I do have one more. And then I know, listen, I had 6. I'm going to do 4, and then I'm going to try to be done and give you some work time, which is a lot, but I'm so sorry. Teaching math takes time. So I have one more, and then we're going to try some on our own. So here's our last one. Unless you're just enjoying the dickens out of this, I can keep going. If you're paying attention, you know exactly where I'm going with this. If you're paying attention and relating today's notes to yesterday's notes, you know, bingo, what's coming down the pike. There's somebody that we haven't seen yet. We've seen a dead root. We've seen a simplifiable, treeable root. We saw a root that could just be rooted. Who haven't we seen? Do you remember? I want you to see what it looks like in the wild when we're doing the quadratic formula and we get a 0 inside of our square root. So here it comes. Is that what you said? So first thing we're going to do is we're going to move the 1 to the other side. We're going to have 9x squared plus 12x plus 4 is equal to 0. And we're off to the races. Let's get this done so you guys can get some work done. What's A? What's B? What's C? Good. So here we go. For the 4th time now together, we're going to use the quadratic formula to solve what it turns out is a factorable quadratic. right? But we're not going to go there. We're going to pretend right now like we're not even looking for factoring. We're just going full quadratic formula mode. So I'm going in. Here I go. X equals what? What goes first? Negative 12. Good job back there. That's the opposite of b, plus or minus a big long square root sign. And what will be first in the square root sign? B squared, which is 144. And I, since my teacher said so, and I trust my teacher, I'm going to do this 100% of the time. I'm going to write minus 4 blank blank over. A little itty bitty math problem. What's 2 times a in this particular case?
18.
And then with a fresh set of eyes and a brain, I'm going to go back and backfill my 2 little cute blank blanks. What are they going to be? 9 and 4. So I'm going to point to something and I'm going to ask you the question that I will ask you every single time. We'll see this again in Algebra 2, and I'll ask you then, is that a keeper minus or a changer minus? That one's like, I'm staying, dudes. There's no negatives after me to make me switch. Yeah, I'm not worried about it. I don't care. So there's nothing to make it switch. And so what's going to happen now is inside the square root, we're going to have 144 minus 4 times 9 times 4. Seems silly to write that again. I just want to be clear that nothing is changing. So if you use a calculator to do this, you would, of course, calculate this maybe first, depending on how much you like to type in at a time. What is 4 times 9? What's 36 times 4? It is. So this really is 144 minus 144. And spoiler alert, you already knew this. It's going to be 0. So we're going to have, for our next step, we're going to have x equals negative 12 plus or minus the square root of 0 over 18. Give me about 20 more seconds, guys. Okay, I'm sorry. What is the square root of 0? It's 0. And what I wanted you to get out of yesterday's practice is that everything in this white box means exactly nothing. In fact, you're within your rights to just act like it never existed in the first place and say, wait, so let me get this straight. X just equals negative 12 over 18. Yep, that's exactly right. It's one answer. Let's reduce that down. What do we get?
Negative 2.
Exactly negative 2/3. So there's one answer to this quadratic equation, and it is x equals negative 2/3. Got it? Okay, so I'll just say this in case for you guys going to track. We're going to work on our Delta math assignment for about 10 minutes. Can you guys put in that much time this weekend so that when I see you on Monday, you will have done the same? Maybe knock out 1 or 2 problems? Rad. Okay. We will have more work time for it on Monday. When you guys go to type these in, so Nash, would you read me what you have for your answer? 2√5. That's it. Okay. Oh, this is a terrible example. What was I thinking? Okay, we couldn't have picked a worse one. There, I was so proud of myself. I'm gonna just make one up real quick. Let's pretend that because there's no fraction in yours, so you're fine. Let's pretend that the answer, and I'm just going to use you as you're going to demonstrate here. So let's say I had like negative 3 plus or minus 2 square roots of 3 over 4. So try right now. I'll just keep the recording going. Try typing that in. And let's see what happens. There's a plus or minus button. Yep. And then there's also a root button. So just use that. Okay, so look at what just happened. Do you see how Nash's fraction happened in a place that he didn't want it? I don't know if you can see that or not, but go ahead and delete the 4. And now arrow to the right out of your square root. And you feel like this will solve the problem. Now hit divided by. But look, it still doesn't work. So the solution over the years, what my students have helped me discover is there's a couple ways to overcome this. Okay, this is no good what Nash has. So go ahead and delete the whole thing, Nash. The best way to do this is right now, hit divided by slash and watch what happens. The fraction's ready to go. Now move your cursor upstairs and type in some stuff And then now you can move freely and create a fraction. If you forget that trick, another way to do it is after Nash typed in his -3 plus or minus 2√3 or whatever he did, you can click and highlight that text and then hit divided by, and it'll also put it all on top of a fraction. Got it? All right. So I'm going to end the recording, and then you can actually type in your real answer at this point.